final example. Okay, let's go back to blue here. If a particle is constrained to move in one dimension only, in the interval from 0 to a, so 0, a, along the real line, here is 0, here is a, it's constrained to move here, back and forth, then it turns out that the probability that the particle will be found between x and dx is given by this function right here. We'll see this again. Don't worry about that. Later when we talk about this thing called a particle in a box, we'll see this again. It turns out to be very, very, very basic and elementary, but very important. So the probability that the particle will be found between x and dx is given by this right here. So this part, notice px, that's the probability density. This whole thing is the probability. This is the probability density. N is going to be equal to 1, 2, 3, and so on. We want you to show that px is actually normalized, and then we want you to calculate the average position of the particle along the interval. Okay, so let's see. They want us to show that px is actually normalized. So the normalization condition is, let's do it here. So the normalization condition is from negative infinity to infinity of this px dx is equal to 1. So we need to show that px is normalized. So we need to show the following. We need to demonstrate that this integral, in this particular case, our space that we're dealing with isn't negative infinity to infinity, it's just 0 to a, of this function 2 over a times the sine squared of n pi x over a dx, we need to actually show that it's equal to 1. Okay, well, let's go ahead and do this integral and see if it's actually equal to 1. So this integral, it's going to equal, I'm going to pull this 2 over a out to, not 2 pi, 0 to a of sine squared times n pi x over a dx. Well, I can either use math software or I can go ahead and look this up in a table of integrals. I get the following. I get 2 over a times, this integral is x over 2 minus the sine of 2n pi x over a divided by 4n pi over a, and we're taking this from 0 to a. Okay, now when I do this, it's going to be 2 over a. I put in a and I put in 0 in here. I'm going to end up getting a over 2 minus 0. When I put a in here, I get a over 2 minus 0 minus, now I put 0 in here, 0 minus 0. So I end up with 2 over a times a over 2, which equals 1. So yes, this is already normalized. Okay, now calculate the average position of the particle along the interval. Okay, well, let's just use our definition of average. Nice and straightforward. So part B. So the average position of a particle, or the average of whatever, that's going to be equal to 0 to a of x times the p of x dx. So it's going to equal the integral from 0 to a of x times 2 over a times sine squared of n pi x over a dx. And again, I can either use math software or I can look this up in a table of integrals. I get the following. 2 over a times, this is going to be x squared over 4 minus x times the sine of 2n pi x over a over 4n pi over a minus, this is going to be the cosine of 2n pi x over a divided by 8 times n squared pi squared over a squared, and I'm going to do this from 0 to a. So when I put this in, I get the following. I get a squared over 4 minus 0 minus 1 over 8n squared pi squared over a squared minus 0 minus 0 minus 1 over 8n squared pi squared over a squared minus this, minus a minus that becomes plus, so these cancel, and I'm left with 2 over a times a squared over 4, which is equal to a over 2. The average position, what this says is the following. So this says that the particle spends half its time to the left of a over 2 and half its time, the other half of its time, to the right. The average position between 0 and a is a over 2. That's what this is saying. On average, sometimes it's going to be here, sometimes it's going to be there. Overall, the average is going to be right down the middle because it's going to spend an equal amount of time to the left, to the right. From your perspective, to the left, to the right, excuse me. Okay, so it says that the particles spend half its time to the left of a over 2 and half its time to the right of a over 2. Okay, this averages to a over 2. So this confirmed, this averages to a over 2. We will definitely see this again when we talk about the particle in a box. Okay, so the things that I would like you to actually take away from this lesson. So the important things to remember. Important things to remember. The P of X is a probability density. P of X dx is the probability of finding something. Between x and dx, and of course the normalization condition. Negative infinity to infinity of this probability is equal to 1, which is completely analogous to this one for the discrete probability. The sum of the probabilities equal 1. This is the continuous version of it. Okay, thank you so much for joining us here at Educator.com. We'll see you next time. Bye-bye.